stream is starting. The Captain Coder at the helm. Bean water is ready. Today we will learn a lot. He loves the questions, he loves to sing. Join our Discord and follow him.
Good morning, good afternoon, good evening to you, wherever you happen to be in the world. Captain Coder here on this beautiful Thursday. Happy Thursday, everybody. Happy 21st of December. I hope everyone out there is having a beautiful day, wherever you happen to be in the world. It's so nice to see all of you wonderful people here. We are back with day 21 of the Advent of Code. Holy cannoli. There's so I can't believe we got 5 days left. That means we got 9 puzzles, potentially 5 puzzles essentially, 2 parts, but day 25, from what I understand, they usually only have a first part, and then you win. And we're gonna see if we can get there today. Punked 20, welcome back, my friend. It's so nice to, or welcome to the stream. It says your first time chat. I recognize that name. Maybe I recognize it from being followed before. Anyway, Punked, welcome to the stream. I hope you're having a beautiful day wherever you happen to be. Happy Thursday. We have the whole crew here. You guys know any day I can wake up and code is a beautiful day. It gets me going. It gets those brain juices flowing. Gives me an excuse to get that bean water going. And I couldn't do it here without all of you beautiful people out there. We got the whole crew with us. Thank you guys so much for being here. Sijian, welcome back. I'm so sorry you got robbed again. 1UP time rating us. We got 1UP. Oh, 1UP. Thank you for rating me. Oh yeah, we've got 1UP. Oh, 1UP. Welcome to the family. 1UP time. How the heck have you been? What were you doing on your stream? Welcome to Captain Coder's Academy. How did you do today on your puzzle? How was your puzzling going? 1UP, you gotta let me know. How did it do? Did you do it? Did you make it happen? Have you been up all night? How do we do? 1UP? Not too bad. I'm glad to hear it. Welcome aboard. Happy to have you here. Folks, if you guys don't know 1UP. 1UP time, incredible programmer. What did you do Rust today? You're doing a lot of Rust programming, right? Or did you do it in Python? Doing the Advent of Code. Folks, be sure to give 1UP time, folks. Attention, this is your captain speaking. This is your Captain Coder speaking. On the screen here, you'll see a heart. You see that heart? You see that heart? If it isn't green, you're mean. You gotta click. Look, folks, click it harder. Look, here's what I'm gonna say. Go make a second Twitch account. Make 3 new Twitch accounts. Click follow. We're gonna give 1UP time all the love we can spare, folks. Click it. You know you want to. 1UP time. Welcome to the stream. It's so nice to see you. How did yesterday go for you as well? Did you manage to finish yesterday's puzzle? But welcome aboard. Happy to have you here on this beautiful day, folks. Sorry, I'm losing it. Look, anything I can do stalling doing this puzzle because someone showed me on the Discord. Look at this. Look, not my personal times. How do I see, what button do I see to see the time stats? Look at this. Day 21. This is a spicy problem, apparently. Actually, maybe not so. Wait. Yeah, look how spicy this problem is. Look at this spicy problem. It's going to be tough. But I want to welcome everyone. Thank you guys so much for being here on this beautiful day. And here you can see an actual competent coder. It's cool. Kavajna tisk. It's true. It's true. All right, look at this spicy problem. This problem. All right, we're going to give it a shot, though. We're on day 21, folks. What are we doing today? We're doing Advent of Code day 21. If you're not familiar with Advent of Code, which I hope you are, if you're not familiar, but I hope you are, Advent of Code is a small program, a series of small programming puzzles, but they get spicier, they get harder, they get bigger as we go. That's what we're doing today. We're doing day 21. We're going to take a looky-loo at it here. But first, I want to welcome everybody in. Mary Cat, thank you so much for being here. G, I appreciate you getting here. Exclamation point first, G, nice job getting that first point. Folks, get those bonus points. Exclamation point first, get those bonus points. Why would you want to miss out on them? There's no reason not to do it. Also, it helps. Look. It helps my ego. Which, isn't big enough. It's not big enough. Help Captain Coder's ego! Exclamation! I need an ego command. Hang on, I forgot to turn on light. I'm coming back. I didn't go anywhere. All right, folks. I also want to welcome back McNeck, Kavadra Tisk. I'm glad you're here, my friend. If you weren't here, Kavadra Tisk, who would heckle me? No one heckles me quite as good as you do. Noyen Rain, thank you for the first. I appreciate it. I appreciate you getting there, collecting those bonus points. There's no reason not to, because with those bonus points, you can get nothing, basically nothing. That's not entirely true. There's a few things, but who knows what. Also, Devro, welcome back to the stream. I'm glad you're here, my friend. BK Dev, I'm glad to hear your studies are going well. Good luck with your freelancing work. Punks20, welcome back. Mick Nets, it's nice to see you. Once again, one up time. Thank you so much for the raid. We also got Dez Tees. What have you been up to, my friend? Thank you for the heart. I'm glad you're here. You one up time says yesterday took 11 hours. Rough. I missed that little part in the chat. I got kind of caught up on it yesterday, and I realized, so anyone who was watching here yesterday, we did finish it almost immediately after stream. Let me show you the bug I had yesterday. So I was trying to detect, all right, so in my input, these were the important nodes. And I was right. It was under under like 10,000 cycles here. I had this thing of has sent high wasn't getting set properly. When I was trying to detect it, once I got that, I was able to do it, and it worked out fine. I had this last thing set, and the thing was in a single button push, they would turn off and then turn on and then back off. And I needed to do it so that it would only be on during that time. Anyway, it doesn't matter that much. Mizzard, welcome back to the stream. Noyen Rain, how you been, folks? Do you guys know Noyen Rain? Yeah, we did manage to get it. Noyen Rain, folks, incredible streamer, incredible game developer. Go check out Noyen Rain, folks. Give him some love. Rain, what have you been up to, my friend? I hope you've been well. I'm glad you're here. Hi, Ten Tandon. Thank you for the first. Welcome back, number 5. I'm doing absolutely fabulous. I hope everyone out there is doing wonderful. Captain Coder's here. I'm drinking some bean water. Folks, let's stall a little bit more with our bean. Cheers to you in the 21st day of Advent Code. So good. I'm almost done with, folks, I'm almost done with all the house stuff. Code Monk, welcome back as well. Hello. All of the efforts that's been going on. Folks who have been here since the beginning, since in the dawn of the 2022 Advent of Code, Captain Coder decided to start streaming. That's why I started streaming. Even I was looking back. I've been talking about moving since a year ago. We finally moved in November. Getting that all squared away. I gotta go back one more time. And then I'll be done. Today is the final day. We're finishing up. We're doing our final inspection at the last house, and then we're done. El finito. That means the finish. All right. We're doing day 21 here. Day 20. Look at this beautiful ASCII art as well. This is cool. It's pretty good. Thank you guys for submitting your solutions. We'll see if we get to them. Cause again, I gotta go after, I might be able to go 4 hours today. About 3 hours is what we're gonna look at. Let's go ahead and read day 21 here, folks. Day 21. See what we got. All right. Try again. Come on, Windows. Stop maximizing. Okay. Day 21, step counter. You manage to catch the airship right as it's dropping someone else off on their all-expenses-paid trip to Desert Island. It even helpfully drops you off near the gardener and his massive farm. You got the sand flowing again. Great work. Now we just need to wait until we have enough sand to filter the water for Snow Island, and we'll have snow again in no time. Well, you wait. One of the elves that works with the gardener heard how good you are at solving problems and would like your help. he needs to get his steps in for the day, and so he'd like to know which garden plots he can reach with exactly his I can't read. Which garden plots he can reach with exactly his remaining 64 steps. Why is that written so weird? Which garden plots he can reach with exactly his remaining 64 steps. It's a weird way to say that sentence in my mind. He gives you an up-to-date map of his starting position, S, garden plots, dot, and rocks. Okay, we got another grid problem, folks. Got another grid problem. You know we love our grids. The elf starts at the center position, S, which also counts as a garden plot. Then he can take one step north, south, east, or west, but only onto tiles that are garden plots. This would allow him to reach any of the tiles marked O. Okay, so he can go to these O positions, doing cardinal directions. So no diagonal movement, only cardinal movement. Then he takes a second step. Since at this point he could be at either tile marked O, his second step would allow him to reach any garden plot with that is one step north, south, east, or west of any tile that he could have reached after the first step. After 2 steps, he could be at any of the tiles marked above the position either of going north, east, south, west. A single third step. Okay. Continue like this until his steps for the day have been exhausted. After a total of 6 steps, he can reach any of the garden plots marked. Oh, okay. So you can't look, you got to use up all your steps. You're not allowed to stand awkwardly in place here. A step is a step only if you move. In this example, if the elf's goal was to get exactly 6 more steps today, he could use them to reach any of the 16 plots. Okay. However, the elf actually needs to get 64 steps today, and the map he's handed you is much larger than the example map. Okay. All right, how spicy is our map, folks? Ooh. Okay. It's not that spicy. All right, part 1. Here's the plan for part 1. This is a breadth first search. Let's take our example. Let's get our example going here. I want to say Proton. Welcome back to the stream, folks. You guys know Proton Fig, the incredible, the fabulous, the one, the only Proton Fig creator of Kart King, folks. Listen to that beautiful music. Listen to that intense music. Makes you want to go drive. It makes you want to Kart King. Look, folks, go get yourself. I got it. Get yourself a C64 controller because you're going to want it. You don't want a Joy. Look, you're going to want a joystick. You don't want this joystick, here we go. You're going to want to get a C64 joystick for Proton's game when it comes out. It runs on the C64, folks, and you're going to want yourself a joypad. A joystick. It's not a joypad. This is a stick. It's a stick. It's a stick, folks. All right. And Goob, welcome back to the stream. How the heck have you been, my friend? Nice to see you. An elf got to keep moving. That's right. That elf's got to keep moving. All right. Let's load up our input here. Let's have a listen to that. Proton, thank you for Zoids. All right, let me pause. How's the volume? Oh, this is intense. All right, Proton, thank you so much for linking that Zoids. Stereo remake. Okay. Oh, I gotta make a project first. .NET, .NET new SLN. Make their implementation, make their tests. CD implementation, .NET new console project. Folks, don't stop being mad at me for not having a script to do this as well. I'm sorry you have to watch me do this. I forgot to do this before stream. .NET new XUnit. I'll try and be quick. Alright, AOC helpers, .NET new add package should leave. And then lastly, pop this up. Let's get our sample input in here. What's interesting is we essentially have two examples here. We have two examples, one for 6 and one for 64. It's the same input, but our part 1 has a slightly different public, static. Sorry. Let's get a commit here. Get commit. Chore initialize day 21. Okay. Let's create a day 21 file. Public class day 21. Public static long part 1 string input. Return 0. Public static long parts 2 string input. Return 0. And then I kind of want a public static long find locations string input long steps or int steps, something like that. Steps. Return 0. The reason I want this is we have two. The music is a bit louder. Sorry about that. All right. Let's. There we go. Proton, thank you so much for sharing Zoid. Sorry, folks, it was a bit loud there. All right, let's take a look here. Nice work, Proton. Thank you so much for sharing your music with us. We're gonna come in here, find locations. The reason I'm doing this is so in our test, this will be day 21 tests. Let's rename this here. Day 21 tests. That music was intense, epic music. Oh, Andrea. Oh man, my voice. I'm losing my voice, folks. X. Andrea, thank you for following. Thank you for following me today. We've got X. Andrea, thank you for following. Welcome to the stream. Andrea, thank you so much for following. If I pronounced that incorrectly, please let me know. Because it might be Andre EA, but I think it's Andrea. Happy Thursday. Did I say happy Saturday? Happy Thursday. All right. Sample public const string sample input. Like this. So we gotta get our acidity sample here, and let's do a theory. And our theory is going to take string inputs int steps int expected. I guess this should be long. And we're saying that inline data for our sample input 6 steps, we should get 16. Is that right? Hang on. Let's verify. Is that what it said? 6, we should get 16, 64. Oh, 16 is, hang on. They didn't actually give us an answer with 64. Nick, welcome back to the stream. How you doing, buddy? How the heck have you been? How did you fare on today's challenge? Time to get paid. You tell me we're not getting paid for this? Nick, are you telling me we're not getting paid for this? Wait a minute. We're not getting paid for admin of code? All right, well, I guess I was wrong. I really thought we needed to do... I thought they had another one with 64. Okay, well. I guess this is useless fact. Public void test sample inputs part 1. I can calculate all the example data from part 2 with my code. Then I just need a tiny step. We'll revisit later. Gotcha. So you're close. You're close. And so we're going to do day 21 dot part 1 sample input dot should be 16. Oh, that's not quite right because all right, no, I'm wrong. This should be not find location sample input 16 should 6 should be 16. Sample input 6 should be 16. So we have a graph. Let's parse this in. Let's parse this in. Public record map. Public map is going to have. We need to be able to index into this. I'm going to store public record map. Maybe it doesn't need to be a record, but let's go ahead and parse in public static map parse string input. We're going to parse in the maze here, or it's not a maze, it's a grid. So this thing has a char array grid. Part of me wants this to be, it's okay. I have a char array grid. Let's go and do string grid. This will just be easier because parsing now just becomes input dot replace line endings dot trim dot split environment dot new lines move trim move empties, and so this is just return new grid of that. Okay. Map. Haven't done any part. Okay. So on our map, let's get rid of. Well, we don't want to get rid of S. We just need to know whether we can move into it or not. We can. All right. So we have a. We need to find our start position. So this is going to be, hang on, string array map or grid. Int position start here. So we find the S in our rows and columns. Grid dot we want to, when we do a where, can we get back our row? We need to know the index of each one of these. Let me just do a for int row. Hang on, do we always start in the center? Do I always start in the center? They did say center, right? Maybe not. Let's just pull it out. Let's just do this. For int row is less than grid dot length row plus plus. For int column equals 0, column less than grid of 0 dot length column plus plus. We could have additional information in here as well. Int rows, int columns. There's nothing wrong with doing this. Int rows, grid dot length, int columns equals grid of 0 dot length. So we'll pull those out to save them. I don't know why. I could do, hang on, input dot index of S. This is going to be our index of S. Int ix. And then we should be able to calculate start ix here. These should be you can do, given a single index, we can pull out the row and column of that. Can do, there's a calculation you can do where it is, oh, I think there's going to be new lines in here. Never mind. Let's go back to what I was doing before. I don't want to make a dumb mistake. All right. Why is column 0 and not grid.length? Is it guaranteed to be a square, Hyper? I don't know that it's a square grid. If it was guaranteed to be square, there's nothing in here that says it's guaranteed to be square. I guess I could look and make sure that's the case. All right, Nick, I'm not reading here that you tell me not to. Hyper, also welcome back to the stream. I hope you're having a beautiful day. Char ch equals grid of row column. If ch is s, he start. I'm a noob asking why I'm not related to. Gotcha. Yeah. So if I was guaranteed it was a square grid, I could use this for both. But this is there's an assumption here that says that every row has the same number of columns though. So there's a little bit. So if we didn't have a square map, it would be an issue. But I think we're okay here. Start is equal to row column break. And then if we can do a little bit of an assertion here. We can do a debug.assert start is not equal to -1, -1. Make sure that we actually found the start position. And then we'll return a new map with our grid, rows, columns, and start. Okay. So we can parse that in like this. And then we just want to do a breadth first search on this, right? So we want to do a breadth first search, not breadth first traversal. We're going to do a breadth first traversal. We're taking an even number of steps. If we were doing an odd number of steps, it would be a little bit different. But we have an even number of steps. So we know that there's a little trick here. Because we have an even number of steps, we know that if I can get to a spot in 2 steps, it is a valid spot, because there's no condition that says I can't just move back and forth between 2 spots. This puzzle will be much harder, and I'm guessing the second part is something like you can't visit the same place twice or something. And so it's gonna be a much more challenging puzzle when you have to find all the spots. You get to 64 steps, or like some giant number, 64 steps, without visiting the same spot twice or something, or you can visit the same spot 3 times or something crazy like that. But 64 steps, because it's even, you can just like alternate. You can go back and forth, back and forth, back and forth. So we mark a node as visitable if it's an even number. Okay. We do need to devise our movement here, so I'm going to do a public enum direction. North, east, south, west. And I'm going to create some helper methods here. Static direction help, static class direction helper. This is going to say if we public static position step this position. This is a thing we've written many times. Direction. If we step in a direction, we step. We're gonna if given a position and a direction, what is the position that direction produces? So we're gonna say direction switch. Direction dot north goes to should just be position plus, and we reduce it here. Yeah, so if we were you could given the number of steps you had, you could determine whether or not you would do it on even counts or odd counts. So we could generalize that as well. So if it was an odd number, we could take a modulus and say, is it even or odd based on the number of steps we start with? And so that one's not too hard to generalize, but we know that we're doing an even number. So I'm just going to encode that here. Throw new exception invalid direction. Okay. So we have the ability to step in a direction. We now should just traverse I think we're just doing a breadth first traversal. Let me think here. Trank says, nothing being visited twice is convenient. For those puzzle, I hijacked the sign bit on the input character as a visited flag. Just to avoid creating extra. Yeah, Trianco. So my thought is the second puzzle today, and I haven't seen it yet, is going to be something like that, where there's some number of times you can visit it. So I haven't gotten there yet, so I don't know. Which is going to make the search space much bigger, and there's going to be some pruning you have to do to make it solvable in a small amount of time, or something. I don't know. I haven't gotten there yet. But let's do a. Thank you for the first, Lance. Welcome back to the stream. Happy to have you here. Congratulations on your position. We have our map here. I want to do a public bool is wall, something like this is wall. So if we're a wall, we can't move into a spot. So there's a few things I need for my map. I need to know if I could really actually do the following: public bool, public I enumerable of position neighbors. So given a position, get me back all of the neighbors of that position. I also want to be able to index into this thing, so I'm going to create an indexer. Royal C-Dub Gaming, hello! Welcome back. Royal C-Dub, how the heck are you doing, my friend? Happy Thursday. What are you up to on this beautiful Thursday? Are you enjoying your vacation? I think you're off of school right now. I hope you're enjoying your vacation, but welcome back. Is it Wednesday? Lance, no, today is definitely Thursday. Yesterday was a Wednesday. All right, so I want to do an indexer, public bool, this position ix goes to, it's going to tell me whether or not I can move into a space here. What I'll do is if we're out of bounds, I'm just going to return false here. If we're out of bounds, I'm going to return false here. So this, we're going to add a getter here. Return true. Okay. So given a position, here, let's do this. Given a position, returns if we can move into that space. Okay. So I'm just gonna have this be a bool here. We're gonna be able to index by a position. It'll tell us whether we can move into it. And the way we do this, we're gonna do grid at row, ix.row, ix.column is not equal to a hash. Okay. But we also need to check the bounds. We're going to say if ix.row is less than 0 or ix.row is greater than or equal to rows, or ix.column is less than 0 or ix.column greater than or equal to columns, return false. Okay. So if we're outside of the bounds, return false. Otherwise, if it's a wall, we can, if it's not a wall, return true. Okay, because I want to ignore the S, essentially is what it is. I didn't parse out the S. Hyper, yes, I can explain the forward arrow there. Give me just a moment, I'll explain it. Real C-Dub says, I'm doing good. I've been just chilling at home. Today is have doubles at swim practice. Nice. I'm glad you're enjoying it. The forward arrow there, the forward arrow is called a, it's a body expression. So let's imagine I have a method here, public void calc value int x, int y. I could do return x plus y. Let's make this return an int. So I have a function here. It just sums these two. It calculates a value. The forward arrow is a shorthand that I can use to say, well, this is a body expression. So it's saying that this is a function that just returns anything on the right. Notice I don't have to put the return there. I just put the expression on the right-hand side of this. So in some languages, you can, in a lot of functional, they'll call this a lambda. But basically, it's a substitute, syntactic sugar for a body here when you have kind of one line of code. So it lets us do that. In the case up here, if it's our getter, we can do this here, saying instead of writing all this code, I could have done this. The problem is I needed two because I had 2 lines of code that I wanted to write. If it was just this part here, I could do that. But I realized I wanted to do a bounds check as well. And so I ended up writing it as a full get. So it's a nicety that C# provides. Also, Classical Uncle, welcome back to this, or not welcome back, welcome to the stream. Have you met Classical Uncle? They are following me today. They're a classical uncle. They are here, and I'd like to say hello. Classical Uncle, thank you so much for being here. Happy Thursday. Welcome to the stream. All right. I might have a off by 1 bug or something in here, but essentially I need to double check. You're welcome. No, thank you for being here. Thank you for being here, Classical Uncle. Are you related to Uncle Scientist by any chance? Because Uncle Scientist is another streamer. I just want to check in. You're not Uncle Scientist. You're the Classical Uncle. Yeah, it's an expression body. And C# has it. Okay. We now, given our neighbors, we can go in all the different directions here. So we can say direction. I'm going to do a thing here for our helpers. Direction helpers, public, static, enumerable of direction. Cardinal is going to be cardinals. Direction.north. Can I do this? Direction.south. Direction.east. Direction.west. And I think to technically make it cardinal, I need to do east, south, west. All right. So I'm going to have a thing here called cardinals. What's the difference between static and void? Static is telling us that this thing is like, you can almost think of static as global. It says where in memory is this data located, and it's saying it's not on an instance of the class. So I don't have to create an object to be able to access this. Instead, it is associated with the class here. Void is a return type or the lack of a return type. So void, so for example, here I'm returning a bool. If I was returning static, public void do a thing, string X. Void is saying that I don't actually return a value. Come on, Francisc, it's not true. It's not true. I promise. There's a few brain cells in here, just a few. There's not many, but void is it's not completely void of things. There's at least 3, maybe 2. Last time I checked, there was 3, but we may have lost one. Royal C-Dub, I hope that makes sense. But yeah, void is the return type. Or the lack of return type, saying this, usually it means that this performs some operation, whereas static, you see how I can do static and void at the same time? This is saying that I don't need a instance of map to use it. I hope that makes sense. So for example, parse here is sort of the way we construct a map. It's saying, given this input, produce a map, but I don't need a map to be able to make one. I can just use this here. Whereas the position, this thing here where I'm indexing into it, I need a map. It's not static because I need a map to be able to find what's inside of it. All right. So now we're going to do direction. Direction helper dot cardinals. Direction helper dot cardinals dot select position goes to position dot step. All right, sorry, this is going to be direction position dot step dir. So we're going to step in that direction. We're going to step in that direction, and then we are only going to keep the ones where we are inside of this of position here. Okay, so this becomes this line of code here. All right, so we're going to get our cardinals. We're going to take a step in each direction, and then we're only keeping the steps where we are inside of the map. I kind of dislike the way this reads, so I'm going to do a public bool is valid position position, and this is just going to be a shorthand for this of position. Can static class be singleton shared between two applications? the memory between the two applications will be isolated. So they will not be this, unless you've done something interesting with processes, they will typically be separate from each other. If it's running in two different programs, they have two different memory spaces. Yeah. As a reference, because it's always awesome when you get a fun client. They're the best. Yeah. No worries. What if it's a DLL shared between apps? I'm not 100% sure. I think even if it's the same DLL, because they live in a separate, and I could be wrong. And Kuani, sorry if I missed you here. Welcome back to the stream. I believe when you start up a program, all right, and so this is sort of what a segmentation fault is. When you start up a program, let me see if do I have my drawing pad here? I don't have my drawing pad. When you start a program, you have what's called a process. Let's see. Let's open up MS Paint. Do I have Miss Paint here? Paint. There we go. All right, we got Miss Paint here. Give me just a second. I'm gonna get my drawing pad here. I'm pretty sure that even if they have a shared DLL is just a binary. It's just a binary. It should be two different classes just because the way the operating system allocates space. Zaliv versus Switzerland.
Pay attention.
Zali versus Switzerland. Happy Wednesday. What a name. Welcome to the stream. Happy to have you here. So come on. Connect. There we go. All right. So when you start up a program on your computer, each process has like a chunk of memory. So the operating system, so this would be app 1 here, and this would be app 2. So if you've ever programmed in C, so you end up with what's called your stack and your heap, and your stack can be thought of as you make function calls. You build up here, and then you have what's called your heap, which is memory that fills from the top down. And so each one of these applications has a stack and each one has a heap. If your stack gets too full, if your stack collides with your heap, you get a stack overflow. If you try and access memory, so your app is allowed to touch memory inside of this square, inside of this rectangle. If you try and access memory that's not here, you get what's called a segmentation fault because the operating system has segmented out this space for you. The operating system said, I'm going to create a memory segment for this process. This process, app 1 has this here, this app 2 has this segment here. So when you get a segmentation fault, it's essentially the operating system saying, hey, you're not allowed to touch that space. This is outside of your segment. And so the DLLs is just a binary. And so you should end up with a situation, I don't know, I have a giant arrow here. You should end up with a situation where you have two different processes running. They will not be able to talk to each other directly. The only way to talk to them between them is you usually create a separate file that's called a pipe. You create a pipe so that they can talk between this here. So you can end up with shared memory here. There's often a pipe. I hope that makes sense. The DLL is just the binary. It's not the actual memory that it's using. So in most, and I'm not saying that this is, there could be an operating system where this isn't true, but this is usually how the operating system works in modern operating systems. Certainly how Linux works. I imagine it's how Windows works. That said, I'm not an expert on Windows. But yeah, I hope that helps. Let's see here. Rose, what was the C# book you recommended? The C# Player's Guide is the book I recommended. It's a fantastic book. I hope that was helpful. And thank you for the little the opportunity to share that information. Points, Ed Nas. Thank you for asking. 50 points. Isn't even more silly than that, as the portable executable can define regions within the DLL that are read-only. Book is great. Kabadra Tisk. I don't quite. I think I'm missing something. Portal as the portable executable can define regions within the DLXL that are read-only. It's. I think I'd have to just sit on that a little bit. All right. That said, we now have a function that will hopefully get us our neighbors is valid position here. Let's do a little bit of sanity checking real quick. Let's do a little bit of sanity checking. Fact. Public void test parse. And we're going to take our map in here. Map is equal to map.parse sample inputs. Okay. And we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 by 11. All right. So our map dot rows dot should be 11. Map dot columns dot should be 11. Our start should be at 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. 5 by 5. Did I count this wrong? Map dot start dot should be new position 5, 5. Our positions around that map dot neighbors of start of map dot start dot should let's create this turn this to an array. Position array neighbors is going to be equal to this. And then we'll do neighbors dot count dot should be 2. We have 2 neighbors from the position, one to the north and one to the west. Memory extensions is a method. Oh, length, because we're an array. Zolly asks, what can you recommend to learn how to create better architecture in C# APIs? The more practical, the better. The book I typically recommend isn't C# specific, but I'm sure C#. Nick Chapsis might have a better Chapsis book recommendations. Nick Chapsis is a person I would check out in general if you're wanting to build C# APIs. Incredible YouTuber who produces lots of C# specific content. He does a lot of C# development. This would be a place to start. Some of his courses might be really good. I don't have a specific C# book for building, but usually O'Reilly, Real World. Real world implementation of C# design patterns I'm not necessarily recommending this book. I'm saying that this might be a good place to start. See if you can get a sample of these. Real world implementation of C# design patterns. Something like this. For doing generic architecture, software architecture books. Fundamentals of Software Architecture. This is a generic book. And then designing data intensive applications. I can absolutely recommend this book. This is not necessarily designing reliable, scalable, and maintainable systems. This book talks a lot about how to do that. It's not necessarily specific in any particular language. And then this book is another good approach as well. This book is one of my favorite books. It's one of the best books I recommend to people. When I was when I was an engineer, here I'll post a link to it too. here is the book I'll recommend here. I'm going to recommend Nick Chapsis as well, but this book is fantastic. Let's make sure this link actually worked. Yeah, this book is so good. I would have my engineers, when I'd hire engineers, I would make them read this book. It's that good. It's that good. Okay. Okay, I hope that was somewhat helpful. Nick is fantastic. Some of his courses are probably a good I'm going to say I've never done any of his courses, but I imagine he has a course called like Zero to Hero, I believe, which is all about, from what I understand, building and deploying APIs into the cloud. Kavadra Tisk, thank you so much for the link there. Allowing writing to a section, not sure what the purpose is. They have, as there are also Bitflux Smart Section as readable, executable, and to allow having it as shared memory. Gotcha. So you load up a DLL, you load up your binary as shared memory, and you can read and write to it from multiple processes. I should just clip Nick is great and run with it. Look. Nick CSS is also good. I have not taken any of the courses. I will say that I enjoy his YouTube videos. Go watch some of his videos, and if they seem good to you, it might be worth checking out. I like his roadmap. I like his C# roadmap. All right. So my parse here. Neighbors dot should be subset of, and then there's new position. The positions that were next to were north one, so 4, 5, and new position 5, 4. Okay, and then we will do like that. Okay, so let's see if this will work. G says won't be here tomorrow. Whole day is already full. I completely get it. I'm gonna be busy today, so that's why I can't stream too long, unfortunately. I'm gonna stream as long as I can, but I have I'm trying to finish up this house. Trying to get out of this. The cursed house is the legacy of the cursed house is almost over. Legacy of the cursed house is almost over. All right, let's just make sure our sample input part 1. Test parse. Okay, so these, I have some confidence. I have some confidence that my parse and my neighbors work here. Van the Noble. Hello, Captain, my captain. How are you today? I'm doing absolutely beautiful, my friend. We are working on Advent of Code, day 21. Any day I can wake up and code is a beautiful day, and today is so beautiful because, Van, you are here making my morning. Thank you so much for hanging out with us. I'm glad you managed to make it today. I hope you're having I don't know if managed. I'm glad you're here. I don't know if manage is the right word, but I'm glad you're here, my friend. What have you been up to? How are you on this beautiful day? Let's see here. We have, all right, so now we want to do a traverse. All right, so public long find valid valid positions. Okay, so we're gonna find all the valid positions from position from a starting position int step. Okay, so given a starting position and the number of steps we can take, we're gonna do a breadth first traversal and find all the positions using, we know that we are, I don't know why this keeps going back to that one, I'm not sure. We know that we are taking an even number of steps. So if we see a step, if we can get somewhere in 2 steps, we are happy. We are happy. That position can be saved. I'm so glad to hear you're having a great day so far. I'm so glad to hear it. That's wonderful. Find valid positions. And I guess I could have this return a set, but I'm going to do a count on it. So traditional BFS here. So a queue of positions, and we need to know the number of steps it took to get here. So it's queue of position and int step. Int total steps. Int steps. Okay. Queue. Turn 0 for now. All right, so we have this. Our visited positions here. I think I'm just going to go with a traditional hash set of position visited. Hyper says, does queue mean list? It's not quite what that means. So a queue is a list that you can think of it as like a line where things come in one end and you pull things out the other end. So a queue, let's go with a new here. A queue is a data structure where when you have two things. You have in queue. It has two operations, in queue and dequeue. And when you in queue things, they go in this side. And when you dequeue things, they come out of this side. So you can think of it as a list, but the order is maintained and you can't access things in the middle. It's just you want to keep the order. You say, I'm going to take things off the front. I'm going to put things on the back. So it's a queue like at like a grocery store or like whatever. If you're going somewhere and there's a line of people, you can think of it as a line. It's not quite a list. It's efficient in removing things from the front and adding things to the end. New York City East 34 Ferry. What a name. Cam. I'm running an RTD server that gets data from server sent sockets. How would you go about writing this specifically? What library for use for server sent events? But confused with that. That's a good question. So let me start by saying I am not a .NET expert. You're doing so. I sadly don't have good advice on like which libraries to use. Do you need to implement the sock and stuff yourself, or can you use an existing library? I'd look for. And I just don't know. Are there anyone? This is where we need Thindle. When Thindle would know. Thindle's an expert here. Nick also does a lot of stuff with C#. I'm not sure. So I'm sorry, New York NYC. I'm so sorry I don't have a better answer. Hyper, don't worry about it. Hyper. I love you that you ask questions. Points at Hyper. For 50 points for asking questions, folks. If I don't have time to answer a question, I won't take the time. Freddy Foo 13, thank you so much for the follow. Have you met Freddy Foo 13? Thank you for following Captain Coder's Academy today. Thank you so much, and I hope you enjoy. Freddy, thank you so much for the follow. Happy to have you here. Welcome to the stream. NYC East, I'm so sorry I didn't have a better answer for you on that. I apologize, I don't have more information. If you join our Discord, I know there's a handful of people there. There might even be more than a handful of people that would be happy to help you. I can think of Thindle will probably have a good answer. Oh man, I can't. There's a few people that I have in mind on the Discord that would probably be able to help you. They're just not in the stream right now. So I'm sorry I don't have a better answer. But best of luck to you, and let us know on the Discord what you end up going with, because I'd like to know. All right, so our hash it here. I just want to find the number of spots that we can visit it into. Yeah, I think that is where I am. We're going to return visited dot count here. At the end of the day, we're going to find a number of things in here. We're going to say, well, and I'm imagining our queue will not get empty, but it might. Queue dot try DQ. Try DQ of out position position int steps question mark, give this thing a name, the try DQ next. All right, so we're gonna pull up the next place we're visiting. We also need to add into our queue dot in queue. We're gonna in queue our start position, and we've taken 0 steps. Our start position, we've taken 0 steps. The visited is nothing yet. Okay, so our neighbors, when we go to visit a step, we're gonna say if current, I should call this current. If our current dot steps is 2, this is a location we can reach. Visited dot add current dot position, so we can reach this position here. And then we still need to continue. We want to say if we have, do we have a, if current dot steps is greater than total steps, we don't do anything. We've reached the maximum number of steps. If we've gone beyond the total number of steps here, we can't do anything. Go to the next one. We don't include it. If we find it here, the steps is equal to 2. Hang on. If we can get here an even number of steps, then we add it. Okay, if we can get there in an even number of steps. It's not if it takes 2 steps. If we can get there in an even number of steps, yeah, if we can get there in an even number of steps, we can just alternate back and forth until we get there. Because, yeah. Yes. Okay. Then we're going to say for each position neighbor in neighbors of current dot position, we want to in-queue this here. Queue dot in-queue. Let me write a helper here. Well, I want an in-queue all. There's not an in-queue all here, which would be great to have. Let's check it out here. Just choose the same as bitwise one. It's true. That's true. Because it's just looking at the lowest order bit. I should really put this in here. Let's just do an in-queue neighbor. But we only in-queue the neighbor if we haven't neighbor, and then current dot steps plus 1. Can we do a thing where we say, can I say if visited dot contains neighbor. This would mean that we've been to that neighbor position on an even count before. I think we can do this. Not convinced. I'm not convinced this is true. Not convinced this check is valid. No, I think it is. I think it is. If we've been to that position, we've already looked at all of the neighbors while we were in an even state. All right. Let's run a test here. Let's test it out. So part one, get rid of find locations, is going to be map.parse input.find valid positions. Oh, this is not return 0. This should be part one. Find valid positions of. We need to take in a second thing here. Int steps. Map equals. Map dot start steps. Okay. We wrote part one to look like that. Sample input. Oh, it's just saying I haven't run it. .NET build. Do we have any compilation issues? Okay. I should have done it in the terminal. I might have an infinite loop. Okay, we pass here. I don't have an infinite loop. Let's do it on our full input here. Trianko, I agree. The intention is important here, and so I left it as a modulus. I absolutely believe that the intention of what I'm doing is to say, is it an even number of steps? It won't be as obvious to someone who isn't. Look, I agree. I think the intent there is important. File.read all text input.txt. Okay. Fact public void test puzzle input part 1. Day 21 dot part 1 puzzle input 64. We don't know what our answer is, so I put it as 0 initially. I need to get my puzzle input. Create new input.txt. Paste that into our test directory. Tuber Tugger, we're always crushing it. We're doing our best. Welcome back to the stream. How the heck have you been, Tuber? All right. I feel like you become the Admiral Cutter during December. It's been a lot. It's been a lot. My speed here seems bad. I should have run this from the terminal. We might have a. Oof. Some optimization I'm missing. Whoa. Uncle Scientist, thank you so much for the raid. Uncle Scientist, thank you for raiding me today. How are you, Uncle Scientist? I hope you have a beautiful day. Uncle Scientist, thank you for the raid. How was your stream? How did you do today? I think I have an infiniteloop.net build here. I think it's going to tell me that, yeah, I think I have an infinite loop. Got 80% of the way through part 2. We're still on part 1. I think I might not be checking against visited before queuing properly. I think I have an infinite queue here. Yes, I've done something weird here. I need to be smarter about my part one. I have a winning solution, but Raiders, welcome aboard. Thank you so much for having you. Thank you so much for being here. I'm so glad you're here. Also, I want to say Profits TV, thank you so much for being here. I can see a wizard flying on a Pegasus. It's true. All right, I'm going to have to kill... Sorry about that. I have to open my task manager here. .NET. I have to kill .NET. I have to kill VS Code, unfortunately. Because I have an infinite loop and the test framework doesn't know how to force kill that. I think .NET is still running it. Let's see here. Are you checking it? Yeah. So we're gonna check it out. Made it 80% through part 2. We haven't even made it to part 2 yet. We've been going for about a little over an hour here. But you know me, I can't help but chit chat the time away, squander my time. Let's see here. County Valve doesn't keep track of visits, so you likely revisit. Yeah, that's what I was saying. I put a little comment here that I'm not convinced this is a valid check. So I'm doing something wrong in that regard. .NET build. I think I need to kill. Yeah, this thing is still going. I always forget how to completely kill this. We're gonna find out if that did it. Nope. All right. And task. Hopefully I don't kill my computer here. Bear with me, folks. There is my whole computer's locking up here. This is so frustrating when this happens. I wish the plugin gave me the ability to kill this thing. It's really hard for me to locate it. And I'm always scared I'm gonna kill my system. Yeah, I wrote an infinite loop. Okay. All right, I was able to kill the process that was the rogue process. Tuber, thank you so much for the alert there. Just so you know, I keep my viewer count off so that I don't have to think about it. I don't have to think about it. So just, you know, try not to tell me too much how many viewers I have, because I prefer not to know. But I appreciate it. I appreciate the excitement there. It is pretty exciting. It's pretty cool. I wasn't being knifed up to my garbage collector. Yeah, I wasn't. Really... thank you for the unknown viewer alert. Yeah. What I care about, hang on. Why can't I think this through here? If we are... There's a bug here too. Hang on. There's another bug here too. I guess not. From the starting position, you can always get back to an even number. Thank you for the first spoof. Welcome back to the stream. My condition here is incorrect. Before I NQ, current steps +1. I don't want to visit. Really, I don't want to visit any position more than once. I kind of want to actually. Okay, all right. I think I want to actually add. All right, hash set position here. So I have a visited, and then these ones are going to be the positions that count. You can count. These are the ones that actually matter. And really, I can do long count. All right, I've done something really silly here. Okay. If we can get there in an even number of steps, we actually do count plus plus. So we increase our count on this one here, but we always add our neighbor like this, and visited dot add starting position. Okay. Oh, it wants me to do this, I believe. Yeah. All right. So all right. So count here is all right. Never visits the same spot twice. I see what I did wrong. If we're on an even number of steps, this one counts. If it's an odd number of steps, well, I don't know if this actually works either. Does this actually work either? I'm getting myself all mixed up here. Is there a situation? If we can get there in an even number, we can move back and forth between it. But if we've already visited it, if we need to visit locations more than once, don't we? Hang on. I don't know why I'm struggling with this. Because you can have a corner or something where it takes, you might be able to get back to this position in an odd number of steps to, is that ever true? 1, 2, because you can't go diagonally or something? Let me think. Like, I don't know if this makes sense to me. Okay. Always claiming to see others go through the same process with the same mistakes or have the same doubts. Always calming. Yeah. Can I get back to this position in an odd number of steps? It probably, yeah, because if I have because we can only do orthogonal. Okay, I think we got it. It's a checkerboard. You can only go from white to black or black to white, but never white to white or black to black. Yeah. Because we can't go diagonal, we can only go orthogonally. All right. All right, do my test here. Just in case I have an infinite loop, I can stop it. Okay. This looks more correct. Okay, we got 1 gold star, folks. 1 gold star. We're going to take a break. Before we read part 2, I'm going to take a quick break. We're going to get some more water. I'm going to get some bean water. I'm going to update my bean water. I'm going to update my fresh water. Mizzard, thank you so much for that. I appreciate it. When we come back, we're going to read part 2. And probably be very, very... we'll see if we come up with a strategy. I don't know that we'll finish. We got about an hour and a half left. We're going to take a quick break. When we come back, we're going to read part 2. We're going to see if we can come up with a strategy and start that implementation. Let's add this feat. Implement day 21, part 1. Yeah. So I'll be back, folks. Hang tight. When we get back, we're gonna get a little bit of stretching in. So get ready for that. Get your whole family together for the stretch. Get your mom, get your dad, get your cousin, call your mom up, call your sister up, call your brother up, call your cousin up. Captain Coder's gonna stretch, folks. Let's get ready for it. I'll be back. All right, everybody, the captain's back. I missed you. I hope you missed me too. Did you miss me? Let me know. One's in the chat if you missed the captain. It's okay if you didn't, though. It's okay if you didn't miss the captain. That's also okay. But I'm glad to be back. We're back here. We're gonna get some stretching in, folks. Before we move on, every hour, every 2 hours tops, 90 minutes usually where we go. We got to get a stretch and we got to stop, take care of ourselves. Look, the captain loves you, which means you should love.
Back. Pay attention.
Pay attention. You in the back. The captain loves you, which means you should love you. And if you love you, you got to love that body. If you love that body, you got to take care of it. And one way you can take care of it is stretching. Stretching. If you're like me, you're hunched over a computer all day, you're clicky clacking away. Some kind of code control, getting those RSIs, getting those RSIs in the shoulders, in the back, in the palms, in the wrists, in the forearms. We got to help prevent those RSIs. One way we can do that, get up every 60 minutes, every 90 minutes. Here, let me tilt my camera down just a little bit here and get some stretches in. So stand on up. I'm going to encourage you. I'm going to implore you. I'm going to engorge you to stand up, folks. Get on up with the captain. We'll get some stretches in. All right. We're going to start out with a nice stretch. Take that hand, reach it up above your head, place that palm on the flat of your back, grab that elbow and pull it across until you get some tension here. Just a little bit of tension. If it hurts, stop. And then we're just going to hold that there for 20 seconds, getting that nice stretch in, taking care of ourselves, loving ourselves, taking care of our bodies because we love ourselves. I know you love you. I love you. You're a lovely person. Captain Coder loves you. You should love you. Oh, thank you guys so much for being here with me, for joining me in these stretches. So nice to have you here with me. Also, I forgot to give a shout out to Uncle Scientist. I believe, can someone, if there's a mod in the chat, we get a shout out to Uncle Scientist. Oh, thank you again so much for the raid, Uncle Scientist. Oh, let it down. Let it down. Take that other palm, reach up, put that one on the flat of your back, pull it across here. Oh, I might, and then I'll give it, oh yeah. If you're not feeling any tension here, lean that head back into it. If you're still not feeling, lean to the side a little bit and just get that nice stretch going. Nice stretch here. 10 more seconds, folks. Oh, doesn't it feel good to be alive? Doesn't it feel lovely to get that stretch in, taking care of ourselves? Oh, yeah. It does. It does. I'm living proof of that. Go and let it down. Oh, let's get a shout out here to Uncle Scientist. Uncle Scientist, one more time. Thank you so much for the raid. Shout out. If you guys want to watch an uncle who does science, check out the Uncle Scientist. Let's go ahead and roll those shoulders. Bring those shoulders up, back, and down. We're going to rotate those shoulders back. 2, 3, 4. Add the elbows. 2, 3, 4. Full arm. 2, 3, 4. Roll them forward now. 2, 3, 4. Add the elbows. 2, 3, 4. Full arms. Yeah. 2, 3, 4. Nice. Shake it out. Shake it out. Doesn't it feel good to get that stretch in, get that blood flowing, taking care of ourselves? All right, folks, we're going to hop back into it. Thank you guys so much for joining me in those. Thank you for getting that blood flowing. Thank you for taking care of yourself. Just some quick stretches there. We're going to come back in. We are going to hop back in here for joining me in those stretches. For joining me in those stretches. 100 points to all you beautiful people. All right, let's bring our desktop cam back. And for being here to witness a completion of part 1, 250 points to all you beautiful people out there. All right, folks, before I start part 2, I always like to take a guess. I always like to take a guess at what I think part 2 is going to be based on part 1. So part 1, we had a relatively straightforward traversal. We had to recognize the trick to part 1 was sort of recognizing, hey, the number of steps we're taking is odd or even. The number of steps we're taking is even, which means we can only possibly reach if we numbered away from us, we can only reach the even numbered spaces. And when we reach an even numbered space, we know that if we alternate between that and a space adjacent to it, that we can get there. So if we get there in an even number of steps, we can get there in the total number of steps, and then we don't have to do a full traversal on it. My guess for the second part is that we are going to have to have a number. The complexity needs to increase. And so my guess is, rather than doing something where you have to do the even number of steps, there's going to be some formula to calculate whether or not something is a valid step in the total number of steps that's going to increase our search space drastically. So our search space, I think the second problem is going to be a search space pruning problem, where it'll be something like the total distance. We're going to have to travel, rather than 64, we're going to have to travel like 1,000,000 steps. And landing on a spot is not as simple as, can we get there in 1,000,000 steps, but can we, something along those lines. Yeah. So that's my thought here, is it's going to be a search pruning algorithm that we have to implement to be able to arrive at a space. Rather than being black and white, sort of like even odd, we're going to have multiple depths. So it's like even, odd. So 1, 2, 3, 4. We'll have to do a mod that's not just a mod 2. But I haven't read it yet, so let's find out together. Let's pull it up here, folks. Part 2. The elf seems confused by your answer until he realizes his mistake. He was reading from a list of his favorite numbers that are both perfect squares and perfect cubes, not his counter, not his step counter. The actual number of steps he needs to get today is this big number, 26501,365. 26501,365. What is that? 1, 2, 3, 1, 2, 3. 26 million steps. Moonus! How you doing, buddy? Welcome back to the stream, Moonus. How is your new job treating you? It's nice to see your name in the chat. It's been a while. Is your new job fully remote too, I think? But how's it going? He also points out that the garden plots and rocks, so we have to take a lot more steps. A lot more steps. He also points out that the garden plots and rocks are set up so that the map repeats infinitely in every direction. So if you were to look, that's interesting. So if you were to look one additional map width or height out from the edge, the example above, you would find that it keeps repeating. Okay. Something that is nice, and I wonder if this is true about ours. Notice that this map is padded with all empty space around the edge. So if we can get to an edge, we know that to get to a next segment is a straight shot. If we can get to a corner, actually, from a corner, it's a straight shot in all of the directions to get to like a next segment. So it's sort of split up into an additional grid on top. This one's interesting because it ends up being odd. So we're no longer looking for an even space, but an odd space. But it says, it is fully remote. It's been very nice, and I'm having fun every day. I'm glad to hear that. Can you tell us what type of game you're working on? Are you allowed to tell us that? Piyush Kurana, welcome to the stream. Piyush Kurana, thank you for following me. Oh yeah, we got Piyush Kurana. Welcome to the family. Piyush Kurana, welcome to the stream. Happy Thursday. I hope you're having a beautiful day. We're working on the Advent code. What brings you to this neck of the wood, if you don't mind me asking? You don't have to answer if you don't want to, but thank you for being here. Hello, my friend. Happy Thursday. We're working on Advent code. Let me repeat myself 7 more times. Never felt this welcome, man. You are so welcomed. You are so welcome. I've never felt a name so wonderful. But welcome to the stream. Moon says, not sure how much advertising I want to make for the game now in the early stages, but it's out in the App Store and on iOS. Very cool. All right, so this is just a tiny 3 map by 3 map slice of the inexplicably infinite farm layout. Garden plots and rocks repeat as far as you can see. The elf still starts on the one middle tile marked S through, though. Every other repeated S is replaced with a normal garden plot. Here are the numbers of reachable garden plots in the new infinite version of the example map. Different map for different number steps. 6. Okay. Okay. However, the step count the elf needs is much larger, starting from the garden plot marked S on your infinite. How many garden plots could the elf reach in exactly insane amount of steps? So there's going to be we're definitely going to find cycles here, I believe. So how do we detect the cycles is kind of important to us here. Something I'm noticing, and I think let's take a look at our input as well. Notice the border is all empty space. The border is all empty space all around. So there's a trick we can use. I think if we can get to a corner, we need but which corner do we pick? And if we look at our code, is it the same? We have some kind of, how much this diamond here is interesting. This is interesting. We have a diamond here. I know that my edge, the S row and column is empty. That's not true. We have obstacles on our S row. And column here. In the real input, but if I use just my real input, I don't have a test case. I don't have a test case anymore if I use just the real input. The example's bad. Gotcha. So, okay. That is really annoying. We have that. And then our column is empty. Oh. Because there's this nice thing here, whereas if we can get to so what's nice about this is we have a repeating pattern where if we get to one and this one, that's so annoying. So I say if we get to an edge, let me look at the. I want to look at our example here. Also, the size of them aren't suspiciously neat as the real data. All right, so we have what I've been calling, I think other people on the subreddit have been calling this a reverse engineering problem. It's sort of a reverse engineering problem where you have to use your input to be able to solve this. What is really annoying here, in my mind, is that we can't utilize this to validate our solution or say, oh, well, we have an off by 1 error or something. We could, but we have to. I'm wondering if I could use that to do a thing where I detect a cycle around our border here. Let's take a look at. It's sort of okay. So I have a thought. How many steps to the? If I could do a thing. There's cycles. There are cycles here. 1, 2, 3, 4, 5. It's an even number to the outside. Well, if we look at mine, it's a little bit harder. What are the how wide and tall is this thing? Let's take a look here. Let's do some investigating, folks. We're gonna do some investigating. Let's open up our if you're in danger, blink 10 times. Dirty Puddle. I'm not Dirty Puddle. I'm not in danger. I'm not in danger. I'm not blinking 10 times. I'm blinking far more than 10 times. I'm not in danger, I promise. I promise, Dirty Puddle, I'm not in danger. Everything's fine. Everything's fine. How are you, Dirty Puddle? How the heck are you? Welcome to the stream. Happy, I keep wanting to say happy Saturday, but happy Thursday. Folks, we have a Dirty Puddle following today. Dirty Puddle, I would like to thank you for following me now, Dirty Puddle. Thank you for following me. Thank you for following, and I hope you enjoy your stay. Thank you for following. Welcome to the Academy. Dirty Puddle, thank you so much for the follow. Welcome aboard. Happy Thursday. Hope you're happy to be here. I'm happy that you're here. Drumunder, I'm ready for the Dirty Puddle song. Yeah. Dirty Puddle, you are special. We're all special. We're special little people. Well, I mean, I'm kind of a big, I'm a big person, but we're special, in the grand scheme of things, we're little people. We're all special people, but I'm a big ol' Abe-tastic followed me. We've got Abe-tastic following me. Abe-tastic, welcome aboard. Oh yeah, well, Abe-tastic, what a name we got. Abe-tastic, helping me avoid this problem. Abe-tastic, welcome to the stream. Happy to have you here on this beautiful day. Hope you have a beautiful day. Lord Extant. Oh, Lord Extant, my Extant. How are you doing, buddy? Welcome back to the stream. I need to take our input file and dump it into my my implementation folder here, because I want to do some things with it. Folks, is there a C#? How do I do the C# REPL? C# REPL. There's a way to do it. I want C# REPL command line. There's a way I can do this. Run C# frit from the command line. I don't think I need to install this thing. I feel like I've done it before. Greetings from Austria! I'm glad you're here, my friend. Only done until Cosmic and Spanish stuff. I got stuck there. Don't give up, Dirty Puddle. Dirty Puddle, I believe in you. There's nothing wrong with looking at, looking and seeing if you find some hints and clues online, especially on the subreddit. Feel free to hop into the Discord room. Spoof, I did finish part 1. We're doing some exploration of part 2. We're gonna do some exploration of part 2. I don't know why I can't get my C# REPL to magic command line REPL here. I want to do this. .NET tool install. All right. Do I already have this here? C# REPL. I don't. We're gonna install the C# REPL. Overlay is wrong. Let me get it. Thank you for that. Spoof, thank you for letting me know that I forgot to turn that off. Look, overlay. Where are you, bum? Boop, gone. Spoof, thank you for that. Spoof points. Add spoof. Let's give you 200 points for that. I appreciate it. JD, folks, we got a legend here. Do you know the legendary, the wonderful, the marvelous, the incredible JD? JD does dev. That name's a misnomer. JD does do dev, but JD does so much more. JD, when you update your name to JD does it all, folks. JD does impressions. Check out this impression here.
I want to feel like you're talking with Captain. Let me see if I could do my Captain impression. I am not the Captain, but my eyebrows also move in a way like the Captain.
Thank you for the impression, JD. Folks, be sure to give JD a follow if you want to watch someone develop. Are you still working on doing fun stuff with OBS screen? Can't talk right now. Doing stuff with Godot, doing stuff with facial recognition, doing stuff with augmented reality. I need to redo that with AR stuff. Absolutely, JD. Find some kind of cycle. Spoof, that's what I'm saying. I think there's a cycle. That's exactly what I was saying. There's got to be a cycle in part 2. And so my plan here is to do just a little bit of exploration here. Can I do a using? I want to import code evaluation. It works. Load file, so we can read a file here. So I'm going to say read R day 21. Will this work? Hang on. Map map m equals new map dot parse. Yeah, it's not finding input dot txt. I want to do this. Could not find it. I'm trying to understand how if I can get this replit to work. I want to. I give it the proj name. All right, R. This is day 21.cs proj. There we go. Reference not added, build failed. Hang on. What are you talking about? Oh, am I in the wrong directory? I am. I'm in the wrong directory. Okay. So, hang on. CD implementation. JD says, I made a bit cannon last night where when bits come, they fire and stick to my face. Interesting. I'm not entirely sure how I feel about that concept, if I'm being completely honest. That is fascinating. A bit cannon. Okay. Let's do a read here. Day 21.cs proj. No, I can't find it. Is it? Oh, I think it's just called implementation. Okay, so I can pull in my implementation here. I'm wondering if it's possible to keep a per tile cache basis, but that would still get really slow if you have a lot of tiled maps. So, spoof. I'm not sure if it's any good. It's a yeah. Let's keep it PG-11 I appreciate that. So now I should be able to do my map parse here. Ooh, it fails. Assertion failed. Okay. Well, I thought I was going to do something cool here. We're just going to do it with I really wanted a REPL here. That'd be cool. Why does that fail? I'm so disappointed here. Hang on. All right. So I need to do the following. I need to do string input is equal to file.readAllText input.txt. So now I have my input here. And now I can do a map.parse input. Okay, so now I have my M. Here is my grid. I have 131 rows and 131 columns. 131 rows, 131 columns in my map here. My start position is 65, 65. You start exactly in the center. Yeah, start exactly in the center. So something that we noticed, something that I noticed is that spoof, something that's really important here is that the outline of our grid is completely blank. It's completely empty. So we get these nice, what I'd call roadways. We get these nice pathways. And essentially, if you can make it to a corner here, you have straight shots between each of the next grids. So you're going to have a cycle here. And someone pointed out even more so, the entire, what's annoying here is the entire row you start in is empty, and the entire column you start in is also empty. So you have these straight shot Manhattan distance steps between your grids, right? So we have this repeating. There's also a weird, this is why, so the weird diamond shape, I believe we don't have that in this. So in the real input, I know. So there's this really annoying thing here of our sample input has some slightly different properties to our example input. And I'm wondering if I should even try and use these as some test cases or not. Or if I should just try and logic. The reason it's hard for me to not just logic my way through it is I'm not able to do any sort of validation here. The diagonal here is only helpful in knowing that if you make it to the edge of this diamond, you have Manhattan. Manhattan distance is really nice. Manhattan distance is really nice for getting places. Let me get my remarkable out. So think of the shape of all reachable positions with a given step count. Yes. So we are going to, let me switch to the dock cam real quick. We have this interesting property. What's 131? Is 131 a prime number? Is 131 prime? 131's prime. So we have this interesting property that our grid is a prime number in width and height. That feels sort of like important to doing cycles. And then this number's interesting. This number is going to be interesting. I don't know how it being prime, it related to so we're like doing a reverse engineering thing. See, like 131 times 131. We have, my thought is the primeness of this is going to help us with our cycles. There's going to be something about that. I could be wrong. This number, it could just be random. Yeah, Dirty Puddle, this is my remarkable. It's the Remarkable 2. It is fabulous. It is very expensive. And from what I understand, I got this when it first came out as a gift. Yes, Spoof. The cost is really expensive. What I will say is the responsiveness compared to every other ink tablet I've ever seen it's ridiculously good. It feels like writing on paper. Here, let me show you some examples. So, other ink tablets cannot do, as far as I'm aware, cannot do this. So this was drawn on this tablet. So it has a ton of precision. It's very expensive. And so here's what I'll say is I did not buy this. This was a gift, a collaborative gift by many people for me. So many people pitched in to get this. Goop Goop, they're very expensive. Here is the thing, I think it is now. I got this as a gift when it first came out, like pre-order. I was talking about how cool it looked, and people got it for me as a gift. The problem is, I believe now it is a subscription cost. Someone correct me if I'm wrong. You might have to look it up. I believe there's a subscription price with it now. So it's like there's a base. It used to be like $500. They're very expensive. The other thing to keep in mind about the Remarkable is it is a no distraction device. It doesn't have, you can't install apps on it. You can't do anything but write on it. Decidian says, I still wait that on the last day will say to make a Dwarf Fortress clone. Yeah. Okay. So what I was going to say here is there's going to be a cycle, right? And our grid is square, 131. So each cell is 131 from the center to the edge. We're going to end up with a situation where eventually we cannot go any further. So the thing that I really dislike about this, the subscription is only for cloud storage. Gotcha. We will eventually end up going outward to a point where we cannot reach any further, right? So there's going to come a point where going from here to somewhere within this grid, you can think of this here, we will end up stopping like this. The other question I have is our input symmetric in some way? That's like the thought I'm having, is there's some kind of symmetry. I also see some things with when I div and module with the steps with this map size doesn't look like a coincidence. Yeah. So determining our cycle is going to be important here. But you're going to end up with sort of a radius that looks something like this. Because we're doing Manhattan distances, we're going to end up with a radius that looks something like this. Let me go one more. Let me go one more out here. On my let's go back. I think just for illustrative purposes, let's go one further, like this. Since infinitely repeating, it's not going to be quite perfect, but we're going to be going out. All right, so we have, these are, so I think what's going to happen is Goop Goop. Yeah, it's like I said, it's very expensive. I never would have purchased it of my own volition. We are going to end up, let me mark these cells here. The neighboring cells, there's going to be a repeating pattern. I keep going. I need to go one more just to visualize the pattern here for myself. Because we have these roadways from the middle outward. All right, so we have this grid here. Eventually, we're going to end up in a situation where we cut off these cells like this. So this is sort of our search radius. So we have these special cases. Since it's repeating here, this node is special, this node is special, this node is unique. So the corner, the edges here are completely unique. So we have this search space here. This is why I was hoping there was some symmetry. It sounds like there's not a symmetry. Because if there was symmetry, then we would know we could look at just like going out one direction. But we have some uniqueness here on this top node. We explore some amount of space here where we run out of moves, right? So if we were to zoom in here like that, we get sort of, this is a space we visit. Similar with, I believe, each one of these should be identical. Is that true? Oh, you know what? It's not quite identical. There's going to be a little bit of potential bleed over here and here. So we're going to have these cells where we have explored this chunk here. So this is going to be this piece here. And then there's this bleed over here where we've explored a small amount. So as we cross the edge here, there's this spot. Is that right? Or does it end up in the, if we had the line coming across here, it should be a repeating pattern for odds and evens. It's not going to be perfectly across the edge like that. It could be something like this, right? So we're going to have this space here that doesn't get visited. Sorry, let me go back here. We're going to have this space here that is visited, and then the space here that is visited. And then this pattern should repeat. This pattern should repeat here. 26B, welcome back to the stream. With $600, you can buy a 60K piece of paper from an Office Depot. Absolutely. Absolutely. The search radius goes exactly to the outer edge of 2023. That's hilarious. But the first will have a stable start offset where the fill-in occurs as you'd expect, so then you can step. You are right about the approach, but first we'll have to find a stable start offset where the fill-in occurs as you expect it, so you can then step. So Nick, there's a crazy thing in the puzzle input where this entire start row, so someone pointed this out. I'm not gonna take credit for this. Someone pointed out the entire start row is blank, and the entire start column is blank as well. So we have this roadway we can move upon, and it's really quite annoying that our sample input does not have that, because you want to assume your entire center is filled due to obstacles. This isn't always the case, so it can take a few for your center to fill, is what I meant. You want to assume your entire center is filled. I don't know what you mean by your entire center. You're saying of my, and you can't see what I'm doing here on my screen because my remarkable. You're saying this center is a special case? I do think, I'm trying to figure out what our special cases are. We're going to have a repeating pattern. I believe we have a repeating pattern for sure here. I'm not sure if that pattern repeats on this side. I'm going to have to do some deep thinking here. I know for sure that we have a repeating pattern ABA across CDC. And the question I'm going to ask is A and C and B and D, are those equivalent? A, B, C, C, D, C, E, F, E, E, F, E, E, F, G, H, G. This is just me logicking my way through it. Yeah, so the center one is kind of unique. We can call that one O. So the question is, does this repeating pattern, it'd be really helpful, because we sort of have like black and white, black and white, black and white. You're thinking about a checker grid here. It would be really helpful if for all of these patterns, we had, you know, A. This is where the symmetry I was really hoping would be here. But I think we're okay with that because the amount of time it takes to get to each one of these is the same. Is that true? And then you have the cycle here where you need to add up, okay, well, how far can I go? How far? It showed illustration on your Discord. What is the illustration of? Yeah, so what is this? Pulling it up on something here. Hang on. Shows the example input after a certain number of steps. Step 30 versus 29 showing a gap in the center, which occurs depending on where you start your offset step. Step before and in number after you will see gaps. So if I step from 30 in increments of 11, the center will never have a gap in the start. Rare Beastie. Rare. You're so rare, you're not common, you're not uncommon, you're so rare. Beastie, you're a rare beastie, and I gotta say thank you for following me. Rare Beastie, thank you so much for the follow. I appreciate you being here. Happy Thursday. Welcome aboard, welcome to the stream. We are working on Advent of Code here. Nick, my mind is in a slightly different place than what you're showing me, and I don't understand what you're showing me right now because I'm trying to logic my way through it. For what I understand here. Here is what Nick is sending. The example input is 11 by 11. Okay. Is this the example input or your input? So I know you're trying to help. I think, okay. This is what I was originally saying, is that in the example input, that's like, how do we get to our edge? Can we calculate the cycle from the edge? I see. So there's like these roadways you can get to that then our calculation comes off. So if we do it that way, that's fine. There is something distinctly easier about our actual input, Nick, versus the example input, where this row is completely empty. And so I think yours is a little bit more general of finding the edge there. This is where you stopped. Gotcha. You feel like you're very close. Gotcha. Okay, let me continue looking at this. You can see the pattern. Yeah, so I'm looking at... Hang on. Let's keep thinking through this here. I have a grid like this. I know I can go out as far. I can go northeast, southwest. My edges are special cases. There's going to be a special case for each one of these areas here at the end as well. These will repeat. These here will repeat as well. There might be some chunk here, but essentially our edges repeat. We need to figure out how many of those we have. This is unique. And then I think we have a repeating pattern for our odds and our evens. So if I believe that all of these will have a repeating pattern within them, and I just got to prove it with our input. Of how much we can get to, because once we get here, we kind of have like an infinite number of steps inside of them. If a tile is full, Smab, welcome back. It's nice to see you, my friend. If a tile is full in one iteration, it'll always be full in the next iteration. Yes, yeah. So I believe that we have a repeating tile pattern of this, and we need to count how many. So these are all going to repeat. These will all repeat here. A, B, all the way around of what we can get into like that. So these ones repeat. So we need to figure out how many A's we have, how many B's we have. We have a special case on the end. So it's like, you know, we have A's plus B's plus corners plus top left edges plus bottom left edges. There's all these special cases. Bottom right edges plus top right edges. Right? So if I can figure out how many we have inside of here, 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 because it has to do with odds and evens, right? Can't you just count how many steps it takes for a tile to fill up if you start at the center of each side? I feel like I should do just exploit the straight lines and symmetry to do valid count and center, but so far IOC says no. Can't tell if my approach is playing wrong or if I'm off by one. This is why I am like really troubled by our sample input. I don't have something that I can test against whether or not this assumption is true. So I may choose a different thing. I may choose a different path if I can't get this to work. The thing about our there's a cycle. There has to be a cycle in this. Let me try my dot cam here. Because we need to figure out how far away we can go. Our cycle here, and then we have a cutoff. It's, you know, so we have these special cases where we want to say, oh, how many can we get in there? So we do have a cycle. What I would like to do, all tiles will eventually be filled up, and once filled, it will stay filled. Exactly, Mizzard. So I can do because the test inputs, my approach, Nick, my approach, I don't think you heard me say this. My approach takes into account, notice my start, the row is completely empty. The row has no obstacles. In the example input, there are obstacles. So in the sample here, there are no, and if I zoom out further, it was also pointed out that in the column, there's nothing there. So you have this clear roadway. You don't have to navigate to the edge. You don't have to find a way to get to the edge first. And so we have the number of steps to the edge is going to be the same to each one. So like navigate to each one. This means that the example will take a while until it reaches a stable pattern. Yeah. Nick, I know that. So part of me is like, I kind of wish someone hadn't pointed this out, because I think there's a shortcut here in the solution. I think there's a short here in the solution. we know we have the okay. So if I wasn't going to do it this way, we can. Yeah. It's a little bit evil, but because of this, we know that the pattern to each section is going to be the same. It has a more special property, and it's really, really frustrating. So I know that because it takes the same number of steps to get here and then to traverse the next one, because it's odd, it's going to alternate between the patterns from A to B to A to B, A to B to A to B. We have essentially, when the example reaches the highways at the top and bottom, the pattern will be stable. Yeah. When we reach that was my initial statement when we were looking at this sample here. The example here was, well, we have to get to the edge to find it. It's basically A plus B plus the border. And the border has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's like 12 special cases for the border, which is really annoying. And then you have no way to test that against these like known cases. So that's part of the problem. But yeah, Nick, it will always be it's not a perfect diamond. Yeah, it's not a perfect diamond because it's not symmetric. Our input isn't symmetric on all axes. It'd be nice if it was, but I already know it's not symmetric because we're missing this down here. It'd be really cool if it was symmetrical, or it would be very different if it was symmetrical. But yeah, getting to our highway is where we can find a stable pattern. So something... Do I want to solve for the general case is a question. I don't think you understood. I'm saying that our map is not symmetric. You don't have to calculate the individual tiles, just look at their sum. I'm missing context. Oh, I see what you're saying. The distance that we can travel, we can calculate how big it is. Spoof, have we made any progress? I believe we've made a little bit of progress. Let me put my doc cam on again. I don't know if you were here when this was sort of discussed. Here is the pattern here. We know that we're an odd number of steps across. So our pattern alternates AB, AB, AB. Okay. So we need to figure out how many A's. You're gone for like 2 minutes. Figure out how many A's we have. So we can calculate how many A slots we have, how many B slots we have. And then we have these special edge slots here where we need to calculate, okay, from this position, so as we come to the edge here, it says from this position with the number of steps remaining, eventually we're going to get here and we're going to have like mod the number, mod the size, mod 131, I believe. It says from there, mod 131, how many positions can we get? And we'll get something that's kind of this diamond shape because we're pretty sparse. But the diamond shape might be, something more like this, right? So this here is going to look like that, the top one. So we have special cases. And then we have special cases for each of our edges along the edge. Nick says if you'd overlay north edge, west edge on top of each other, you'd get what northwest side would look like. This is what I'm saying, won't it? I think there's enough going on that I can't understand what people are saying, and I have this idea in my head of my approach. And you couldn't see what I was drawing down there. I believe this will work for my input. The thing that is really frustrating about this is I don't know that I can This will not work for the sample input because it takes us some amount of time to get to the edge. And so the problem I'm having with the sample input, so with the sample input, we don't have these straight shots out. I'm trying to think, can I generalize it here? So with this sample input, we have to calculate, and this was mentioned, I believe, by who said it? The stable pattern, was it Mizard? Or Trienko? Someone mentioned that you'll end up with a stable pattern once you reach the edge highways. And that's true. So we can almost think of it as like a cycle problem. It says, okay, well, how long does it take to reach our stable condition? And for our puzzle input, the number of steps to reach stable is 0. The number of steps to reach stable is 0. In our practice, in our sample input, if I could start here, for example, or here in the top left corner, we'd have the same thing. So the question I kind of have is, can we figure out how many steps to stable? Here's another tip. What is the final left point on the map? Yeah, we can calculate that using the size of our map. So we have the size of our map is 131. I can say, long total steps is equal to this thing here. Okay. And I could do, what is it? Total steps mod 131. We end up with 65. Buckville, thank you for the follow. Buckville. Oh, Buckville. Thank you for following me today. We've got Buckville. Oh, Buckville. Thank you for the follow on Thursday. Buckville, thank you so much for the follow. Welcome to the stream. Thank you for coding. No, thank you for being here. You're welcome. I love coding. So, mod 131. Hang on. Would it be total steps divided by 131? Sunset took you 10 hours. It was rough. We're logicking our way through it. We have a total steps. This is like how wide. Hang on, because we got to get to the edge of. Hang on. If we get to the edge of our initial grid, right? We've taken 65 steps. 65 times 2. Here. That's how many tiles, yeah, in each direction. This is a thing here. Where on the map would you end up? Yeah, so 65 is how many steps I need to take to reach the edge. If I took 66 steps, I'm on the new one here. So I can go after 65, you land on the edge of the starting tile. Yeah. You can go exactly 20 that many tiles further. And so that's our, you can think of that as our radius around this. So in my picture, that's sort of how many times this thing repeats. And so I want to calculate my number of steps here is like, if I have, I end up doing an odd number of counts. in this because our total is 265. I need a button for my doc cam. Someone solved this in 14 minutes. Congratulations to them. It wasn't me. It wasn't me for sure. I have 30 minutes, so I'm probably not going to finish this on stream. We have... Why did I type? Oh, 130 is how many steps? We have an odd number of steps we can take. So here's the thing. If we can reach a tile in an odd number of steps, that means we can go on to that tile. It might lead nowhere. That's fine, Smav. If we have an odd number of steps, we can get onto that tile. And the tile is an odd number across, right? We have 131 across. So to get to the next tile, we alternate ABs, ABs. So I believe the problem I'm struggling with here, I hate this example input. And maybe I should focus on solving it for the example input so I can test some stuff out here. I want to get to corners. Is that where I want to get? The corners feel special to me. Gotta think this through completely. Spoof, exactly, exactly. This is why I don't know if I should take into the account here. Oh, there absolutely is. There is so you could probably do something from this is what I'm saying. If I can get to a corner, if I can calculate getting to the corner and then doing it from, okay, so then we say how many steps from the corner, right? So if you get to the corner, we know that our cycle, so Spoof, we have a cycle, right? And so we end up adding those extra, we subtract those steps from our total. All right, so we can say, sorry, 1 second, I need to add a doc cam to my stream deck. Hang on. Stream. I'm turning my doc cam on and off, and I don't want to keep switching back and forth. So you guys get to see how it's made. See how it's made. I'm gonna add a doc cam here. So on my stream deck, I have these buttons. I want to add in a doc here. So instead of what, I'm gonna change this to doc, and it types doc here. So if I save this, now when I press that button, my doc cam will turn on and off, and I don't have to manually type it. I have a button now that'll turn it on and off. Okay. Without having to switch where my mouse is on the screen, switch my cursor. So we have a cycle. We have a cycle here that creates this pattern. And if we can say getting to a corner, we can say, okay, well, where is our stable position? Where's our stable position? I know if I get to a corner in my example input, I have a stable. So I start here. There's some number of steps I have to take before I end up being stable. There's some number of steps where I have to be stable. And then I can say, okay, well, now solve the rest of the problem from here, right? So if I can solve how many positions, how many positions from corner minus steps to the corner, right? So if I can solve it from there, and it says, okay, well then, can we come back? So the question is this puzzle identical if we just shift the starting position somewhere else? Can we just shift the starting position somewhere else and figure out, is it the same problem given a different starting position minus the number of steps it takes to get to that starting position? Is that the same? And I think it is. I think it is. So, if we change our start position to this corner and we move our map, right? So we say, okay, move the map so that our center is here. And then we say, okay, well, how many steps does it actually take to get to that position? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps. So then we reduce our total number of steps by 10 here. Is it the same problem? I think it's the same problem. I posit that it's the same problem as starting from the center if we shift our center here. And then say, well, it took us 10 steps to get there. Right? So it'll take us 10 steps to get back. And then, so the question is, do I subtract 10 steps or add in 10 steps? I think if we do that, we have the same puzzle. We have the same puzzle where we're in we have a condition here. And the question is, it took me 10 steps to get here. I'm not sure if that's true. I'm not sure if this is true or not. Science, welcome back to the stream. We're losing our minds a little bit here on this puzzle. Trying to see if we can come up with a winning solution to it. But I hope you're having a beautiful day. Balint, how have you been? 1,001 times 1,001 times the original map. So my map was pretty big to do 5K steps. Doing okay. I'm glad you're doing okay. Better than bad is good. Better than bad is good. So is it true? Is it true that if I shift my starting position here, and remove and adjust the steps, so it would take me that many steps to get here? That's my question, is can I adjust my center? And what is the correct number of steps to adjust it by? So that I have to take the same number of steps here. Yeah. Any of the 50 garden sets, 10 here. Because we have like the sideways diamond you were showing in your examples. We reach a stable pattern at this point, is what I'm saying. So when we reach one of these corners, we have a cycle. So Nick, there's a thing here. When we reach a corner, we have a cycle. Yeah, so I'm thinking that, but from that won't quite make sense here. What we could do is from this corner. I'm trying to think through. I think my other approach is sound. I just don't have any test. I'm not able to test it. Also, folks, if you're not following Science Streams, be sure to give Science Streams a follow. Incredible educator, entertainer, father, just incredible human being. Be sure to check it out. Whack-em Wednesdays. We love Whack-em Wednesdays. We got Microscopy Mondays. We got all kinds of fun stuff going on. You stream. What are you doing tonight, Science? What's going on tonight? Also, I missed it, but how was the charity stream on Monday? How did you do? It says, find the first time all fill grids outside of your starting grid are fully filled with every possible step, then map the edges and try to extrapolate. Find the first time all fill grids outside of your starting grid are fully filled with every possible step. We're going to end up with a cycle though. Yeah, so the idea is I need to find my cycle. And I don't quite understand how to detect the cycle right now. Here. We could... There's a cycle detection that needs to happen as we move out. And... Well, we can say... Yeah, so you're saying find... You're saying I'm going to find when all of these 9 grids, the 8 around you, are fully filled. How many steps it takes to get there is somehow you're positing something. Then map the edges from that state is what I was trying to say. We could... So... Yeah, I don't quite know yet. I really like my solution. My idea feels so much easier because of this. I really hate this one here. Detecting the cycles is tricky. On this generalized input. I really feel like there's something from the corners. Oh, I see what you're saying. So these steps here, I want to know. I'm still stuck on this corner aspect thing here, I think. I still want to explore this. I definitely think I need to run it more times. Yeah. The target number is odd, but all the tests use even numbers. There's something really interesting about it. And I think I do think simulating the full number of steps out could be really interesting. At some point, you're going to find a cycle where there's going to be a pattern to how it is increasing, right? So there's going to be a pattern to how this number increases. So I think what we want to find is, when does this pattern double? Like, how many steps to double it, or something along those lines. And Nick, if we were having a verbal conversation, I could understand, but because I'm streaming, the segmentations of seeing your conversation with me, it's not adding up for me in my mind. It's too challenging for me to understand because our conversation has been segmented. So I know you're trying to help, but it's too segmented. My theory is to do with how many rocks on even and odd points. Interesting. The area of a rhombus is O of n. The area of a rhombus is O of n squared. It's this where n is the side. Is a rhombus a square? Like all the sides are the same length. It's just the angles, or is that a parallelogram? I feel like that's a parallelogram. So I'm not 100% sure. Dandy McGee, welcome back to the stream, says, is a garden plot a single hash or the contiguous island of hashes? So a garden plot is one of these blank spots. The hashes are walls that we can't move through. Rhombus. A parallelogram with opposite equal acute and 4 equal any parallelogram with equal sides including a square. Yeah. All right, I want to so I like this idea of writing. All right, given a position, let's do this. Total steps here. There's an important thing here where it is we need to know if our total steps is odd or even. Okay, so int mod bool odd is even is total steps mod 2 is equal to 0. Okay, so we want to know whether or not to count. Okay, and is even, else if not is even, count plus plus. Let's make sure we don't break on our puzzle input here. Yeah, I have a bunch of stuff I got to do today as well. I have about 15 more minutes. Oh my goodness, did I do an infinite loop again? Please don't tell me I have an infinite loop again. Ugh. Smab, thank you so much for hanging out. Remember, keep coding, keep growing, keep being amazing, my friend. Have a beautiful day, and good luck with all of your endeavors. There should be a thing called test. Or is it using up a bunch of memory? I have an infinite loop here. Why is there not a search feature in our task manager? The top is far superior than task manager. What is going on? Why is this really still running? .NET. I'm losing my mind, folks. This isn't related to that, I don't think. Let's find out. That isn't related to it. It's not that C# is too slow, it's that I have a... Oh, interesting. That is interesting. Can I make... Okay, so maybe I don't have an infinite loop. The REPL is what was interfering with the build somehow because of implementation. Let me try something. Make their REPL. It would still be remove. Let's see. CD REPL, C# REPL. R // it's not going to let me do this. This would be 21 implementation. Implementation.csprout. Does this interfere with that? It must have like a .NET watch. .NET that makes sense. It was because I was in that directory. Apila, thank you for that. I gotta read these things. I just jumped to conclusions. And topologist, welcome back. All right, I didn't break my input here. I want to... Now I should be able to do find valid positions. All right, so let's... I'm gonna move my sample input here. I'm gonna move these into day 21 here, so that I can have them for our samples. Let's come back here. Let's reload this. Map sample map is equal to map.parse day 21.sample input. We should have our sample map.grid like that. Okay. And sample map.find valid positions, sample map.start 6. Position is defined in an assembly that's not referenced. Interesting. So I have to AOC helpers. AOC helpers dot csproj. The type position is defined in assembly that's continent position P. Did it not let me import that? I'm trying to learn this tool here. AOC helpers should have position in it. Interesting. Interesting. Can I load a... One second. Let's open up a second terminal. AOC helpers. Yeah, I don't know why. Oh, I have to do using Captain Coder dot Captain Coder position. What is the namespace? Is it not? It's in AOC helpers. Okay, I got to do using AOC helpers. There we go. Why? I can do that. Oh no! Spoof! Spoof, I wanted to find it. Why is it position? I don't understand why find valid positions. The type position is defined in an assembly that is not referenced. I don't understand. Sample map dot start. Sample map dot start. It's an AOC position. I'm really confused why. You must add a reference to the assembly AOC helpers. All right, let's try. Is it because of the folder I'm in? .NET, right, CS, C# REPL. I'm just trying to understand this tool. It'd be really helpful for me to have this tool under my belt to use it. R implementation.csproj. Using AOC helpers. Okay, that doesn't work. C helpers. AOC helpers.csproj. Using AOC helpers. Position P. Day 21 dot sample inputs, map m sample map. It's going to be our map.parse sample map. It lets us do that here. Sample map.start. Okay. Sample map.find valid position. Sample map.start, comma 6. Okay. I did something weird here. Live Coding says, and welcome to the stream, Live Coding. I have knowledge of dynamically loading assemblies in REPL environments, and I'm sorry to say I don't know how your C# REPL tool does it. I'm pretty sure they're using. I haven't used this tool. If you want to find this tool, C# REPL. I didn't use it. I didn't write this. I'm using this one here. You want to look at it a little bit to understand it more. You might find an issue information here, but it is dynamically loading it. The thing that I wish, and maybe I need to learn how to do it, is I wish I could pull some stuff in there. But yeah, check that out. So I was gonna say, as we grow, right? Oh, my map is not an infinite map here, actually. So I'm realizing that I need to redefine my map a little bit. And I'm wondering if I can start this up with like the specified projects loaded. Thank you for that, Nick. I only have 4 minutes, so I'm still gonna I'm gonna keep playing around with this. My map here is infinitely repeating. So can I have to find this interesting here. Can I make this part here repeat? And will that break part 1? When we do we can do mod rows, mod columns to end up back at the edge. Here. Can I configure a start in this tool? If it's -% will be negative. Yeah, so there's a little wrapper we have to do around that where we do int row is ix.row mod rows plus ix.row mod rows. Thank you for pointing that out, Mizzard. So I don't know if I need that extra one. I'm sorry, plus rows mod columns. This will account for our negative positions. Can I pass in some arguments to this? Configure to launch this file in your editor. A file with the RSP. Ooh. Containing lines of C# to evaluate before starting the REPL. Okay, let's. Okay, so we should be able to do REPL. Let's create a new file REPL.csx. And is there a default one it looks for? We want this to do R implementation.csproj R. Stop it. AOC helpers. AOC helpers. .csproj, and then using AOC helpers. Could not be opened. Cannot find file. What do you mean you couldn't find it? It's right there. Oh, line 7. Nope. Source file reference could not be opened. Could not find file. My guess is it's saying that it couldn't find the autocomplete here. Change language modes. Text. Not. AOC helpers. Cat. AOC helpers. AOC helpers.csproj. I don't know why that. File with the RSP. One option per line. File with this containing lines of C# to evaluate before using the REPL. Okay, so I can't load in this. I want to specify our reference assemblies, NuGet patches, and CS project file can be specified. Okay. And using here. Okay. So this is not delete. REPL.sh. I want to do this dash R implementation .csproj dash R helpers.csproj. And then I do want to there's a AOC helpers. All right, so now I should be able to do REPL bash REPL. Okay, so this will load up my environment for me. The operation cannot be completed because the build is already in progress. Do I have position? Position. Don't. The operation can't be completed because the build is already in progress. I don't understand that. Is it telling me that I need to pass this as one comma separated thing here? Congratulations, G. Congratulations. All right, folks. Unfortunately, I do have to go. I don't want to. I really want to finish this. I might be back later today to finish this up. Today is the last day. Today is the last day of finishing stuff up at my last house. Congratulations, G. All right, everybody. I got to get out of here. I'm so sorry to leave this unfinished. Check out the Discord for updates. Check out the Discord for updates. I have ideas. Here, but I really got to test a bunch of stuff out. We'll be back. Who are we gonna raid? I gotta get out of here quick. Let's raid one of my favorite people in the world. We're gonna raid Practical NPC, making one of the best games that I've ever played. If you like, it's working in Godot. We're getting a dough, but he is making a... Why can't I grab the edge of this? The new update to Chrome makes the edges tiny or something. I've been struggling ever since there was an update here. We'd raid him. He's doing Memory, a precision platformer, absolutely beautiful, fun game. All right, we're gonna raid Practical NPC, folks. As always, remember to keep coding, keep growing, be the best you can be, and you're welcome back anytime. Have a beautiful day. We'll see you tomorrow for day 22, folks. Have a beautiful day. Bye.